Good morning, everybody. Welcome to the day 2 of our Woody Invasive Species Summit. This is session number 4, Integrated Strategies for Woody Invasive Control. We're going to have a series of 4 different talks for you today. Really excited about all of them. They kind of deal with different aspects of control, and then also one's talk specifically on integration. And then we're going to end up with about a 20-minute panel discussion at the end. So I encourage everybody that's listening in to enter questions in for each individual speaker. But as we get close to the end with the panel discussion, enter some of those larger questions that you want us all to address. Just starting things out, I'll be the first presenter. So I'm Chris Evans from the University of Illinois. And I'm going to talk about choosing the right tools for mechanical control of woody invasive species. And this talk is going to be kind of a general overview instead of specifics about mechanical control. When is it applicable? When is it really not? What are some of your options? So again, more of the basics and a general overview, and then the speakers to follow after me will kind of get into more detail on different aspects of this. But just jumping right in, woody invasive species are some of our worst invaders, as I'm sure you've heard all the time. We deal with multiple ones and multiple control techniques, whether they're shrubs like this, trees or vines, anything together. And so understanding the control and understanding your control options is very important. I always like to start any talk when I'm talking about woody invasives just with a little history, understanding kind of where we came from with invasives and kind of our changing thoughts about these and how historically we brought these over. Most of them, we encouraged people to plant them, we spread them around, and we viewed their positive benefits, and you can't argue that they do have some positive benefits. It's just only afterwards that we realized that the negative impacts of those greatly outweigh any positive benefits. But I kind of collect these little pamphlets like these on different invasives, and you can see, Multiflora Rose for living fence and autumn olive there for wildlife. And I just love that the wildlife that they chose to highlight was the exotic ringneck pheasant. But anyway, kind of the outline of my talk, I'm going to talk a little bit about woody invasive species ecology just for a few slides. And I think that's important because it highlights kind of how we need to approach them control-wise. Get into those mechanical management options, as well as just a little bit of kind of options when you look at an integrated approach. And then spend the last few minutes talking about choosing the right options in terms of what do you have to take into account when you want to decide what's your best approach, what's the option that you should take to control. But just a little bit about woody invasive species. Many of our woody invasives, particularly our woody invasive shrubs, have bird dispersed seeds. And so they're going to spread throughout the woods or lands fairly quickly sometimes. They do tend to move into predictable ways when they have bird dispersed seeds. A lot of times they'll show up first, in edges and fence rows and things like that. But that does give them, the ability to spread rapidly. They vary quite a bit in seed bank longevity, with many of them actually having a very short seed bank, but with others having long seed bank. And that's important too, because you understand the seed bank longevity can help you figure out the commitment you need for follow-up. For the ones with very short seed banks, a lot of times your focus then is really killing those plants, and you don't necessarily worry too much about doing it before or after seed set because there's such a short-lived seed bank. You can get them with the first follow-up, whereas some of those with longer seed bank ability, you have to be concerned a little more about when the seeds are ripe and what you do with those. Almost all of these woody invasives sprout aggressively following some type of mechanical damage. They'll come back from roots or from suckers. And so that, again, that kind of, you have to take that into account when you're deciding what your mechanical options and why you can and cannot use, or how to use those, understanding that many times just simple mechanical damage, leaving the roots intact, are not going to yield the mortality of those plants in many cases. Many of the invasives, woody invasives, have extended leaf phenology and others do not. And again, that just opens up some possibilities for you in terms of control, in terms of survey and finding those. This time of year, you know, we're looking at things like this with amber honeysuckle, highly visible when most everything else isn't. And then if you're looking at integrating approaches and looking at herbicide use, it does give you a window at some times to control those and really give you some selectivity. Most of the woody invasives that we deal with respond positively to disturbance. They take advantage of disturbance on the landscape very well. This is a shot here of autumn olive in an area that was slated for some tree planting. It was an open area then, cleared, and the autumn olive really aggressively moved in following that disturbance. Many of the other species will do that. So any kind of management you do, whether you're disturbing due to trying to mechanically control the invasives or doing other type of management that on the landscape that has involves disturbance, we know that invasive species, these woody invasive species, often respond aggressively following that. Some invasive species, some of these woody invasive species are clonal, others are not. So this is tree of heaven. We know that it moves through roots, spreads through roots and forms these big clonal patches, which complicates control, particularly mechanical control, a lot. We know that often mechanical damage will stimulate clonal species to root sucker even more aggressively. So again, that's just some of the general ecology behind these woody invasives, and understanding that a little bit, and you'll see how it plays out in terms of making our management choices. And then just to highlight our management goals, what we're trying to do when we're managing these species really is to reduce, prevent, and eliminate the negative impact from these invasive plants. So that's what we're trying to do with managing these, and we're trying to find the right methods that are the most successful ones to do this, at the same time protecting our desirable species on the landscape, and then taking into account cost and ease and complexity and other factors. So when we get to management here, I'm going to start just going over mechanical control options from the most basic to more and more complex, and kind of highlight the negatives and benefits of those. And the first one is real basically, it's basic no tools. So we're talking about hand pulling options out there with gloves. And that is an option at times for different invasive species, particularly ones that are shallow rooted in areas that are smaller that we can pull up. This is an option for certain situations. So hand pulling things, we tend to think of it more for herbaceous species, but it does work in many cases for woody invasives. And in general, you know, the positives for hand pulling, it's a really good option for volunteers, since there's really no training or little training, no licensing, no capacity issue. So you don't have to know how many volunteers you're getting since you're not using particular tools. So we can really flex with the number of people you get. It's positive as it works on some species. Small diameter stems, running vines like winter creeper or Japanese honeysuckle, smaller bittersweet, things like that, it can work. But there's a lot of negatives. Overall, with most of our woody invasive species, there's really limited applicability. Most of them are too large to be hand pulling out there. And so you're limited, very kind of limited on when you can use this method. It does have some potential for ineffectiveness through stem or root breakage. You know, you might transfer fruit or seeds around, and it does tend to promote soil disturbance some. Kind of moving up, mechanical pulling aids. So that picture there is a weed wrench. These are popular. and they're out there and they give you mechanical leverage and assist you and basically increase the size of the plants that you can pull out of the ground. So this is often used in conjunction with, hand pulling. And there's a bunch of them out there, anywhere from poppers to polar bears, extractigators. There's a bunch of different ones out there, and we're not recommending one over the other, but there's a lot of options. And overall, these pulling aids, they're good for volunteers. Again, no training or licensing. They work on many species as long as it's small diameter stems and particularly shallow rooted species. And they do work in many situations, particularly loose, uncompacted soils that have adequate moisture that you can pull them out of the ground. But they do have some negatives. They are heavy, so it causes fatigue. I always call them the best thing for somebody else to use in the woods. They don't work on many species, large diameter stems, or deep-rooted species, since they only work on shallow-rooted species. That doesn't work in some situations, dry and compacted soils. And again, just like the other one, it does tend to promote soil disturbance. Moving up, there's some growth suppression aids. And so these are smotherers, you can think of them. Some like using heavy duty weed mat, like we see here with on knotweed, or buckthorn baggies or something to put over stumps to prevent or smother out the sprouts as they come back. And so there's several other kinds of these, but basically, again, you're putting something on the ground or on the plants to try to kill them that way. So these growth suppression aids, positive is there's multiple different options out there that fall into this. Many of these are inexpensive and potentially reusable time and time again, which is nice. It helps with expense. Another positive is they're good for volunteers. There's no licensing, no permits available, but they do have limited applications. And so again, you're limited by the size of the plant necessarily, maybe the location of what you can put on the ground or not. It does leave materials on site for a long time. And then so that sometimes is a problem if you're working in areas where the public's in there, things like that. So you have to take those into account. And so sticking with just mechanical control, the next is kind of land clearing equipment. And we go from the basic ones all the way up to the kind of extreme one, which is, forestry mulchers like this. And these are used, different ones are used different ways, but they all kind of share the thing that they're using a mechanical damage or removal of the above ground portions, of sometimes even larger woody invasives. And some of this land clearing can be real super basic and small scale, whether you're using a tree shear mounted on the front of an ATV, some of those push along mowers, big bush hogs on the back of tractors, all the way to some of these chains and grabbers for pulling things out of the ground. So these are kind of the basic levels here. But then there's others, more advanced or larger equipment out there that you can have, whether they're root grapples, things like this, or as we mentioned, the forestry mulchers. And so these, again, grind things up, move things down, and get them down to the ground. This is a site that we did just here at the ag station that I work at that was heavily dominated with large autumn olive and bush honeysuckle. And we came in and ground it down, got it down to zero, which was nice for us. But knowing that, again, these species sprout aggressively, we know that they're going to come back. And so that's something we have to take into account. There's going to be sprouting. So these land clearing or forestry mulching options, the positive is it's a really good way to kind of do an initial attack on heavy infestations. It does set it back to ground level, provides access for follow-up, and it's kind of an instant change in looks. There's contractors out there that are available. The downsides is it's expensive. It requires experience and specialized equipment to run, heavy site disturbance, which may promote other invaders, and there's always follow-up needed. And then there's other talks on integrated, but I'll just mention that there's other tools out there for integrated management that you use in combination With herbicide treatments, I really like these kind of handheld brush cutters like this. It's really good to use in combination with herbicide for cut stump treatments. It's a great tool for mechanical. But there's others to use in these integrated approaches where you're combining them with herbicide. Hatchets, brush axes, chainsaws. We're playing around now looking at using cordless drills as an injection method for herbicide, and it seems to work really well. There's a bunch of things. And then integrating with prescribed fire, we're going to have a talk on direct flaming next as well. So these, again, other methods that you can integrate. One thing that's being looked at a lot lately is growing season prescribed fire for invasive species as a method, following it up with treatments after that. But this is a site here. You can see a lot of heavy honeysuckle, but if you can get it just right with a growing season fire, you can really impact that honeysuckle greatly. Knock it back. So in some situations, you know, that's a tool that you can use in combination with some of these other methods. So there's a lot of things out there for us. So kind of understanding when to use what are our options? There's things to take into account. And really when you're making those decisions on how to approach controlling invasives and you want to incorporate mechanical control, you've got to understand what is feasible. What can you do? What's practical for you to do? What's costly? And then what do you have capacity for? And just as an example, if your honeysuckle that you're dealing with looks like this, small diameter stems kind of spread throughout, your options are going to be very different in terms of what you can and can't do than if your honeysuckle looks like this. You know, when they're this big, you're limited in some of those options. So again, kind of understanding that will help you understand your capacity for sure. And so you need to look at these questions. You need to ask yourself, what's the severity of your infestation? Do you have small or new infestations with smaller plants? Then you can look at some of these methods like pulling that do individual plant treatments. So you have the capability of treating one plant at a time. But if you have large, dense, established infestations, then you're going to have to probably, you know, what's more practical would be looking at group treatments, land clearing, or you know, herbicides applications or something like that. So, you know, knowing what's feasible on that land starts with kind of knowing the severity of the infestation that you're wanting to address. And then just understanding capacity issues. What time and resources do you have available to work on those infestations? Are you doing this with in-house staff? Are you trying to use volunteers? Are you using contractors? What's the funding you have if you have contractors? What's the training level of your volunteers or your staff if you're using those? What equipment do you have on hand to do, and what can you purchase if you need to? Understanding those questions will let you then select the right choice of the choice that you have the capacity to do. And then just looking at things like control feasibility. What's the seed bank potential of the species that you're addressing? Is it a long-lived seed bank? Has it been there for a long time? If so, then you can expect multiple years, you know, of germination and follow-up needed. And that's different if it's a new infestation or a species that has a very short seed bank. What's the accessibility to the site? Is it easy to get to? Can you get equipment on the site? Can you get volunteers on the site easily? What's your permissions? If you're federal lands, do you have the NEPA analysis that lets you do certain things or not other things? Is there any other management ongoing on site? Do you have forestry harvest going? Are you looking at prescribed burning already? And then what's the follow-up commitment? Can you do the necessary follow-up equipment? Do you have the staffing and the funding to come back in afterwards and do that necessary follow-up? Again, understanding what you have and what the feasibility is will let you choose the right option. In terms of priorities, knowing what your priorities are. Are you dealing with established or incipient infestations? Which ones are you looking at first? Is your priority kind of those new ones that are actively spreading, or is your priority maintaining a site and kind of keeping or working on these established infestations and controlling them? what's your priority? Or do you have significant resources at risk that your top priority is protecting those? They may be rare native species, intact natural areas, or something you had a significant investment in, like putting money into a tree planting that you want to protect. In those cases, those investments become your priority for your management.
Hey, Chris, just about a minute.
Okay, thanks. And then just understanding clonal species, your priority with those is preventing the stimulation of root suckering. And so you may want to avoid mowing, prescribe fire, cut stumps, something that does that kind of mechanical damage but leaves the roots intact. Instead, you may want to look at pulling it, basal bark injection, or something like that, and definitely following up. And so just to end, kind of putting this all together, this was really brief and just the basics, but mechanical control should be a part of any integrated management approach, and understanding kind of the different options for mechanical control, the techniques that are available, and their positive and benefits are really vital so you can make the right decisions. And then making those decisions again requires understanding kind of the feasibility, the capacity, and your priorities so that you're being the most efficient and the most successful, and then making the right choices. And that is the end of my presentation, and I'm assuming, Claire, that we don't have time for questions for me. So I think we'll just move right into our next presenter. But again, if you have questions for any of our presenters, even if we can't get to them at the end of the presentation, go ahead and put them in, and that way we can address them at the Q&A session at the end. But Kurt Dreisilker from the Morton Arboretum is going to be talking about integrated management of woody invasives in a remnant forest ecosystem. Kurt, I think you're muted.
Okay, sorry. Can you hear me now?
Yes.
Okay, thank you, Chris. My name is Kurt Dreisilker, the head of natural resources and collections horticulture at the Morton Arboretum, as Chris mentioned. My role at the Arboretum is really to do land management within our remnant forest. Jeff a minute ago was talking about how his boss would fire him if he started a wildfire. My boss hired me to do prescribed fire, but he also said if I ever hung up on him, I'd be fired. So I try not to hang up on him. Anyways, just teasing you there, Jeff. So if you're not familiar with the Morton Arboretum, let's see if I can get my slideshow to start presenting here. All right, there we go. If you're not familiar with the Morton Arboretum, it's located here in northeastern Illinois. You can see in DuPage County outlined in white, and then the red outline is the Morton Arboretum itself. We have about 900 acres of natural areas on the property, including most of which is a remnant forest, which I'm going to talk a little bit more about. But part of what we do here is we grow trees in our collections of plants from all over the world, and we grow them here on the grounds, and they're sort of centralized in the center of the Arboretum. But you can see a few images of some of the landscapes within the Arboretum, and this is really an important part of what we do here for ex situ conservation, because a lot of these plants are actually threatened at some level in their home ranges. But these collections, like I mentioned, are kind of consolidated into this interior green portion of the Arboretum. The exterior part that's not shaded in green is really that remnant forest that we focus more on in situ conservation. Throughout the entire Arboretum, we do control about 55 different invasive species, so we have our work cut out for us, many of which actually have their ties to horticulture, and some of them have actually been introduced into our collections many decades ago, which is actually the subject of a different talk. But with respect to managing invasive species, we actually use a lot of the common tools and resources so many other land managers use, including the hand tools and equipment like the mowers and skid steers, herbicide, fire, staff and volunteers, many of which Chris was talking about a little while ago. But I'm actually not going to focus on these details of these techniques in this talk. I'm going to sort of zoom out a bit and make sure that the invasive species control is linked and coordinated with other aspects of what we do. The Morton Arboretum was founded almost 100 years ago in 1922, and in the more recent decades, we've turned most of our invasive species-ridden forests into rather species-rich functioning ecosystems over time. Really, as the years turn to decades. And so the title of my talk uses the term integrated, which really means that it's linked. The parts are linked or coordinated with other aspects. And we've done this type of work by using the many tools that are commonly shared by land managers, sort of exemplified in my previous slide. So you can see here an image on the left with an invasive species-ridden forest, a lot of honeysuckle and buckthorn in the understory, kind of in the lighter green color. And over time, with proper management, we've turned them into species-rich forests, as I've been referring to. Today, we really do this work by integrating invasive species control into the process of ecological restoration. So invasive species control is part of ecological restoration, but it's not really the entire aspect of it. Land managers like us, or like myself, typically spend so much time and effort and budget controlling invasive species, but we really need to remember that controlling invasive species is part of that process. It's just part, but it is actually a vital part of that. So we can see here the definition of ecological restoration. It is a process of assisting the recovery of an ecosystem that's been damaged, degraded, or destroyed. And so essentially what we do in this process is focus on adjusting the various biotic and abiotic components of the ecosystem and sort of giving it a big jolt to reset the ecosystem's trajectory. And this is oftentimes where invasive species control is so important. A lot of work is given to this during this stage. And then we allow the ecosystem time to react and allow these natural processes to occur. And then ongoing management will be necessary to sustain the recovery of this ecosystem. So while the general understanding of ecological restoration has actually developed over time, we have been applying the principles of forest restoration here at the Morton Arboretum since the 1980s. And we started this primarily by introducing or reintroducing fire. Back then, we thought this was really the main or the only ingredient needed to restore forests. We did this by using fire in this invasive shrub-ridden forest. This is the actual site where we began our work. But we did this without using herbicide or any other hand tools to control invasive species. We simply burned it every year. And this was the beginning of us learning how to restore forests. And so what you see in this image here is the road separates the left side from the right side of the image. The left side has remained unburned during all that time, whereas the right side has actually burned annually since the mid-1980s, or virtually near annually. And so some key lessons that we've learned over time in this forest has been that light levels, they increase in the burned section due to the impact of the shrub layer. The increased species richness results in the annually burned forest, and the species richness increases on its own as a result of the burning's impact on light levels. In other words, we didn't reintroduce the flora. This is a remnant system, so the native vegetation has responded on its own. Burning virtually eliminated the shrub layer, though. And so whether it was invasive or native, it was virtually eliminated. But the size threshold of the fire's impact remained at about 10 centimeters. So stems larger than 10 centimeters persisted in this forest, whether it was native or invasive. And so by the time I entered the scene in the mid-2000s, there actually were there was a substantial population of large diameter woody invasive shrubs still on site, until about 10 years ago when we broke out the chainsaw and we started cutting the remaining individuals down in this forest. And so this is the stump of a Remnant cathartica, the European buckthorn, probably one of the largest ones that we had on our site. So we now use fire with other components for a kind of a 1-2 punch to tackle these invasive species. So switching gears here a little bit, another important component of this work is understanding what the land use history was in this forest. One of the first projects I did was to research what happened in our remnant forest in the past. And so I pulled in information from various sources, and you can see a new layer was just shown here. This is the Public Land Surveyor's notes from the 1840s, which helped us to determine the former boundary of the timber grove, as you can see outlined. Then I pulled in the property deeds that I got from the local county's office, and we can see who owned the land and where those property lines were. After sifting through the property deeds, I could pull out the timber lots used by people primarily for harvesting trees in this former timber grove, but really not much else. Then I could pull in the earliest aerial images, and I could see how it all looks together. And it really does a pretty good job telling a better story. So in doing this, the history comes alive, and it can help me understand where some of the parcels are within the historic grove that may actually offer better opportunities to restore forest. So within these small timber lots, as you can see outlined here, I could rely more heavily on removing invasive shrubs, and then really allowing the native flora to come back in on its own. So no introducing new species into the site was necessary for a good portion of these parcels. The strategy was chosen to give it time and proper management moving forward. And so it's in areas like this where we started burning since 1985 that I just spoke about a few minutes ago. So this is kind of an example of a situation that happened with our long history of fire. But actually not all forested areas are created equal. You can also see along the edges of this timber grove where they were sort of straddled by landowners from the 1800s as they established farms and grew crops and grazed livestock more heavily, ultimately causing more ecosystem degradation. So I've learned sort of the hard way that if I were to go in and control invasive shrubs in these sections, I might end up with sort of a lackluster response from the ground flora. And by removing the invasive shrubs, I might just get a whole bunch of other herbaceous invasive species in their place. So this image here shows in a kind of an example from the ground level of what I'm talking about in one of these remnant sections here. This is kind of an early part of the restoration process where we've controlled invasive shrubs and began thinning the canopy in the image on the left. And then we're allowing the natural processes to take place. So using prescribed fire and giving it time to facilitate the response of this ecosystem. So that individual plants, as we shift our eyes over to the right, individual plants and small patches of native species that are found early on in this process, they're scattered around, but give this process a decade or 3 perhaps, and the flora should respond pretty well, given that we still maintain control of the invasive species and use prescribed fire and other good management techniques. So it's really sections like this that I have no plans to reintroduce native seed or any native plants. I just want to use the various tools in sort of the management toolbox to facilitate the natural processes and let the natural processes take over. So ultimately, land use history makes a big difference in the strategy of controlling invasive species here. So I'm going to switch gears a minute, and I'll talk also about one of the functions of the Arboretum as a public garden. We have many of these non-native species planted throughout the property that come from all sorts of other regions, as I mentioned earlier, which is an important component of ex situ conservation. This is an important component of our mission because, as I mentioned, we have a lot of threatened species that come from other parts of the world. And so we give them a home here by planting them into our collections, which are quite useful for other people to study and to reintroduce in some cases, back into their home range, that is. But we also see that some of these plants on occasion can escape from cultivation where we have them planted. And you can see in the image the emer cork tree, Philodendron amurense, which has been shown to escape from cultivation within our collections and within our property. So this puts a different twist into developing an integrated management program to control woody invasive species within an arboretum, which we really specialize in cultivating woody plants, because you can see they sometimes do spread around. And what you see in the bottom image is actually a lot of cork tree seedlings and saplings in the forested understory. So it turns out actually many other gardens experience situations like this, not just with emer cork tree, but with many other taxa that are escaping cultivation within the various gardens. So a number of us, including Claire Ryan and Teresa Cully, myself, and several others from these organizations, have found this out by opening up this discussion with the public garden sector specifically. And so we started this initiative called the Public Gardens as Sentinels Against Invasive Plants. And what this is, well, this is an important component of this work, will help us to eradicate these taxa, like the cork tree, from spreading from cultivation. The well-established taxa I've been using throughout this presentation, like Rhamnus cathartica, the bush honeysuckle, and so on, you know, I focus on controlling those rather than eradicating those. But in situations like the cork tree, I focus more on eradication in those situations. And one of the important outcomes of this initiative is really the recommendations to remove taxa which are considered problematic from within our tree collections. As a matter of fact, if you're interested in learning more about this topic, I'd invite you to my presentation coming up in just a little bit, which I'll actually focus more on this as well. But again, the point of this is to think forward instead of thinking backwards about the land use history. This initiative thinks forward about controlling invasive species to detect these taxa as they become problematic. And with that, I will finish up. So thank you very much. And Chris, I'm not sure if we have any time for questions.
We do. Thanks, Kurt, for sure. So we have some time for questions, so I'll definitely encourage people to submit questions. I did have a question about your burning when you talked about that, and especially your annual burning. What kind of other impacts, were there negative impacts that you saw from that annual burning as well, or kind of, can you explain a little bit more of the changes that have resulted from that?
Actually, yeah, that area has been the study area for other people to look at what else is happening with respect to those annual burns. It does actually impact the nutrient cycling. So we've seen offsets in the carbon and nitrogen cycles, which actually can make it more challenging to grow young oak seedlings, for example. So one of our soil ecologists just published a paper on the nutrient dynamics going on there too. So that is one of the probably more adverse impacts of this annual burning. And then some of the physical observations I've been making out there as well is that, you know, after so many years of this frequency of burning, we've certainly seen that elimination of the shrub layer, but we're starting to see impacts on the canopy as well, because these relatively low intensity fires are moving through the ground, but they also are starting to have an impact on the canopy trees by, you know, scarring the larger diameter trees that are dominant and co-dominant. And so we start to see some of these trees falling and failing over time too.
Okay. A question came in about bird nesting, particularly in these sites where you've done spring burns, you know, with these regular burns. Have there been anything that looked at changes in bird nesting success?
So we have, there are some studies that have shown that. We have not done those ourselves, so I can't say I'm up on the current literature with that. But I would say that we do have an active monitoring, we do have an active group of monitors checking on birds. And so our volunteer corps is actively monitoring this site plus other sites within our forested area and tracking birds. And we do have a lot of additional bird species that are utilizing the site. We also go in and replant native shrubs, maybe not necessarily in this little parcel of the woods that I'm referring to, but as a general management practice, we are certainly introducing and reintroducing native shrubs too, because we recognize the value that they have for nesting habitat.
Great. We have time for one more quick question. Somebody asked, have you had to deal with the aggressive native sedge, Carex pennsylvanica, at all? And if so, do you manage it on your sites?
We do have some, and it's certainly more populated in some areas of the woodlands than others. But as far as managing it goes, no, I wouldn't. We've never had to manage that. In fact, I wouldn't think I would need to manage that. It's an interesting idea. I would welcome some of that sedge on the site here because it is a native sedge for us.
Okay, great. That's all we have time for now. If anybody has additional questions for Kurt, go ahead and submit those and we can try to address them at the end in our Q&A session. But now we're going to go ahead and move on to our final presentation. So Ron Rathfon from Purdue Extension is going to present on prescribed grazing for managing invasive woody vegetation in eastern hardwood forest.
All right. So I'd like to start out by acknowledging my co-authors on a publication that'll be coming out soon in Restoration Ecology, Skye Greenler, who was a former graduate student at Purdue, now at Oregon State, and Mike Jenkins, professor of forest ecology in our department. Okay, there we go. I'd also like to acknowledge the farm crew at the Southern Indiana Purdue Agricultural Center, where we implemented the research that I'm going to describe. Jason Tower, the superintendent there, and his farm hands, of course, were very instrumental in managing the livestock that we used in this study. I'm a forester, not an animal person, so they were pretty crucial to the success of this. And Songlin Fay at Purdue, Mike Neary, Extension, small ruminant specialist at Purdue, and Ken Andrews at Kentucky State University, all were very helpful in initially establishing this trial. So Karen Launchbaugh at the University of Idaho defined prescribed or targeted grazing as the application of a specific kind of livestock at a determined season, duration, and intensity to accomplish defined vegetation or landscape goals. So with good grazing management, the focus is on outcomes with the animal. With prescribed grazing, the focus is on the outcomes with the vegetation, the plant community. And it's not a new concept. It's been used for a number of decades on Western rangelands for controlling non-native invasive weeds. And we're seeing some more recent applications in the East, notably kudzu management in the South with goats. But there's currently little to no data on the long-term effectiveness of prescribed grazing for controlling non-native woody species in eastern forests, nor is there any data on the impacts of native, on the impacts of native plant communities. And so we wanted to begin testing prescribed grazing to better understand under what situations it would prove useful as an integrated vegetation management tool. some historical context. The forestry profession spent the better part of the 20th century trying to get livestock out of the woods. And so the idea of reintroducing livestock to the woods is a little bit of a sell for foresters, I think. But like prescribed fire, fire was once considered one of the great evils in the forest by foresters. And now we take a much more nuanced approach and recognize that the fire is a very useful tool in the management of forests. And so in the initial trial that we established, we wanted to begin testing some of the parameters that can be adjusted, such as stocking rate and number of grazings per season. And so our immediate objectives for this initial trial were to test the effects of prescribed grazing using goats on non-native woody species and hardwood forest understories, and then determine the impact on native vegetation. Long term, we hope to be able to develop prescriptions for integrating grazing into an integrated management program for hardwood forest understory maintenance and restoration. So we established this, as I said, at the Southern Indiana Purdue Agricultural Center on a mesic east-northeast aspect slope. In fact, earlier efforts at trying to manage the invasives on this site were to use prescribed fire. Because of the mesic nature of this site, prescribed fire couldn't be done in the spring. We just didn't have good burning conditions at that time, so we were limited to fall burns, which only seemed to reinvigorate and stimulate the primary invasive on this site, Multiflora Rose. Very steep terrain, which is can be very challenging for conventional control methods using mechanical methods, herbicide methods, but might be ideal for prescribed grazing. The overstory was mixed mesophytic with a high component of tulip poplar. The shrub layer was dominated by Multiflora Rose and spicebush. Multiflora Rose comprising 56% of the ground cover, spicebush comprising 20%. We had a pretty diverse, rich herbaceous layer in there as well. So the treatments that we initially chose were to test animal stocking rates and also the number of grazings within a growing season. And so we had a low stocking and a high stocking rate, 16 goats per acre versus 48 goats per acre. We had one grazing where we just grazed in the spring versus two grazings, once in the spring and then once later in the summer after there was sufficient regrowth. The treatments were applied to 1/4 acre paddocks. And initially, we didn't have a time limit set for the number of years we were going to attempt this. The initial idea was to see how many years it would take to get significant mortality in the target invasive vegetation. But we ended up stopping it after 5 years. And following 5 years, we did follow-up control using cutting and herbicide methods to finish off the invasives. So we used mature open does and immature does, Boer, Kiko, Savannah, Spanish influence, kind of a mixed breed that's good for meat production and also pretty self-reliant in a more wild setting like a forest. We used portable electrified netting, and the goats were removed from a paddock after they completely stripped the forage. So when they were initially put into a paddock, goats like to browse at head level initially, and they do have some preferences, and they kind of work from favorite to least favorite. They are generalists, so there isn't much that they won't eat. But eventually, after they start depleting the easy to reach forage, then they start stretching upward, reaching up higher, and digging deeper into dense thickets. And so you can see in the photograph on the lower left, they create a browse line. And you can see the dense Multiflora Rose shrub there that's completely stripped of foliage. They really dug in deep and pretty much stripped every little bit of green leaf matter. So after 1 year of grazing, we decided to go in and cut shrubs that were greater than 8 feet tall, those that the goats couldn't reach, so that forage would become available to them as well in subsequent years. Now, they not only browse, but they also rub their horns, stripping bark, girdling stems, and breaking stems. So there's a significant amount of damage done in that manner as well. So initial results in the first year, we have a before and after photograph here on one of our vegetation sample plots. And this is the low stalking rate. And you can see that within 1 month, this is the level of foliage reduction that the goats were able to achieve. An 84% reduction in Multiflora Rose cover. Pretty phenomenal, pretty astounding result. And the high stalking rate, pretty much the same result, but it took 1/3 less time than the low stalking rate. Now looking at the data over the 5-year period, you can see with the non-native shrubs in the left graph that we had a gradual incremental reduction in percent cover of the non-native shrubs. And all of the grazing treatments produce significantly lower non-native shrub cover than the untreated control. Now, in terms of low stalking and high stalking, not a significant difference that way. But when we look at the low stalking 1 grazing treatment right here, and the low stalking 1 grazing treatment down here, or 2 grazing treatments, I'm sorry, you see that the 2 grazings per season definitely produced a much lower percent cover, and it was significantly different than the 1 grazing treatment. So over time, we're seeing that the 2 grazings per treatment is starting to have a much more significant effect, more rapidly reducing cover than the 1 grazing per season treatments. Looking at the native shrubs, we see a sharp reduction with the grazing treatments in the first year, and then it levels off, a much more gradual reduction taking place. Keep in mind that this first year reduction in cover also includes the cutting of the shrubs that were larger than 8 feet tall. Looking at reductions in height, we see the same gradual incremental reduction in height of the non-native shrubs, which they were then significantly lower or lower in height than the control treatment. And we can see the same thing with the native shrubs. Okay, I thought it would be kind of neat to look at a time sequence over the 5-year period, one of our sample plots. Okay, this is one of our sample plots at the beginning of the first grazing season, before any grazing had taken place. Very dense Multiflora Rose cover. Here's at the beginning of the second grazing season, and we're starting to see a little bit of ground, the forest floor showing through the canopy. We go to the beginning of the third growing season or grazing season. We're seeing a lot more of the forest floor showing through, and we're starting to see a little bit of the herbaceous plants starting to respond to the increased amount of light that they're getting. Beginning of the fourth grazing season, a lot more cover or ground, the forest floor showing, and much more of the herbaceous vegetation starting to, to respond. And the beginning of the 5th growing season. Now, looking at the impact on the herbaceous plant community, and that first growing season, we saw dramatic reductions in the herbaceous cover, and then a leveling off at a lower level of herbaceous cover. In terms of species richness and diversity, this is a Shannon's diversity index here on this graph in the lower left. The lower right is Purdue's evenness index. We're seeing an upward trend in richness and diversity over the 5-year period, at least until the 4th year. The only significant differences occurred in richness with our high stocking rate, 1 grazing per treatment. It was produced significantly greater richness than the control. But I think the important thing to note here is that though, yes, we're seeing a dramatic reduction in cover, we are seeing at least no reductions in richness and diversity compared to the control, compared to just letting the invasives continue. And in fact, we're seeing some signs of perhaps some improvement, at least up until year 4. Then we start to see kind of a downward motion in the trend after year 4. Okay, as I said, goats are generalists, but they do have some selectivity. And there were some of the herbaceous species that the goats seem to not touch at all. Wild ginger was one of those, twin leaf was another. You can see here the Multiflora Rose canes that have been completely stripped, revealing the herbaceous plants underneath. Okay, to conclude, Multiflora Rose is extremely resilient. And so, we were able to produce modest incremental annual reductions in cover, but it required 5 years of grazing to produce approximately a 40% reduction in cover. So, it's a tough one to kill. We didn't see any mortality, and multiple grazings per season tend to reduce woody cover more quickly, as you might suspect, than just 1 grazing per season. And up to 4 years of grazing tended to increase herbaceous vegetation richness and diversity, or it was at least neutral. Beyond 4 years, we may start to see a reduction in richness and diversity. And so we have to keep that in mind, that there may be a point beyond which the grazing may be counterproductive in that regard. Prescribed grazing definitely opens up the understory, facilitating future conventional mechanical and herbicide treatments. Thus, we can reduce the amount of herbicide that we have to apply and the associated labor costs. And there's definitely a psychological benefit that I can't underrate. Even after that first grazing, it was like, wow, this gives me hope. I think we can actually manage this. And so I think that prescribed grazing does definitely have some possibilities. And it's not a panacea, but I think used under the right circumstances and the right conditions, it's another tool to add to the toolbox. Questions, maybe some future inquiry. How will the plant community recover over time? Well, we're actually looking at, we're actually collecting data beyond the grazing now that we've finished the control, the follow-up control. We're going to look at how the plant community recovers over time. So we're continuing to monitor those vegetation sample plots. Another question would be when and where prescribed grazing is appropriate. So trying to, looking at integrating prescribed grazing into integrated vegetation management systems and developing prescriptions you know, it's an important next step. One of the, the real challenges, I think, to implementing prescribed grazing, at least in Indiana, is developing a herd for hire industry. And so there's a real lack of that. And so perhaps with, being able to come out with some prescriptions and a little bit of education, perhaps there'll be more of our goat producers that will look into developing a herd for hire industry. Okay, I don't know if we have any time for questions.
Hey, thanks so much, Ron. Yes, we have time for some questions. I'll encourage anybody that has questions to go ahead and submit those. We've had several come in already. A couple questions came in wanting more details about the time frame that the goats were left on the sites, for your each treatments. I know you said it was until the vegetation was depleted, but kind of what did that look like time-wise?
Right, yeah. So in the initial year, of course, over time, the amount of time that they were in there diminished over the 5-year period. But in the initial grazing year, the high stocking rate took about 10 to 11 days to deplete a paddock. And then the low stocking took about 1 month.
Okay.
So, it was directly proportional to the number of goats. Then in subsequent years, high stocking rates, we were putting them in, towards the end, they were in for, maybe 5 days. The low stocking rates were, maybe about, half a month.
Okay, great. Somebody asked, did your data include seedling and sapling multiflora rose reduction, or was it just kind of larger plants? How did you collect that data?
Yeah, we didn't differentiate between seedlings and mature plants. It was just the overall percent cover within a sample quadrat. Okay. So just an estimate of the cover.
Okay, sounds good. At this time, it's 9:50. So what I'm going to do, if you don't mind stopping your screen share, Ron, I'll invite the rest of the presenters to come back on. And then we're going to jump into the kind of extended Q&A session for this last 20 minutes. And so again, encourage anybody to put questions in to particular speakers or just questions you would like all of us to address. Either one is fine. But I'm going to start with some that we didn't get a chance to get to. And Jeff, I'll start with some with yours. Somebody wanted to know more details on the cutting blade, the 3-sided cutting blade that you recommended.
If you could give somebody else a question for a second, I'll bring up a quick picture of it and put it up.
Okay, great. Well, I'll address a question that came in for me then real quick. Somebody had a question for my talk about more details about the drills, cordless drills for injection. And so that is basically, it's similar to what we consider a hack and squirt or an injection where you take a hatchet and expose the cambial layer under the bark. What we use is this drills for the same thing. So we use a cordless drill, high speed, with a 1/4 or 3/8 inch drill bit, drill down at kind of a downward facing angle, 1.5 inches to 2 inches in the tree, and then put a milliliter of herbicide, concentrated herbicide into that hole. Very similar, you treat it recommendation wise like you would the hack and squirt. It seems to work pretty well. We've done it for maple, tree of heaven as well. The one caution we've had with maples is making sure that you do it at the right time, because if it's in the winter and it's starting to warm up at all, we had some issues with sap flow and pushing out the herbicide with that. I like that method. It's pretty fast. It tends to really hold the herbicide in place, so you have very little non-target impacts. And I know, Ron, I think you've done some stuff with that as well, drill applications, or have you?
Nothing that I've presented or published. I just did a trial using it compared to the injection hack and squirt type.
Gotcha. Okay.
Using method.
Okay. Jeff, you ready to share that picture of that?
Can everyone see it in back of me?
Oh yeah, there we go.
So yeah, we actually found that blade. We got it because we found with a regular saw blade, we had to sharpen it. It seemed like every time we filled the gas tank, because it was repeatedly dulling. We got this blade thinking we could flip it over, at lunch, and we actually have never had to flip the blade. And it'll rip through stuff up to 1 inch in diameter. If anyone, there's probably not a problem. We also have a problem with running bamboo, invasive bamboos. It just chews through anything like you can't believe. If you're dealing with Multiflora Rose or with Japanese barberry, somebody with spines, we use what we call the Vegetation treatment, where we lift it up and then bring it down through, and we actually can cut a path right to the base of the plant. So, a lot of times they might go out 3 or 4 feet and you can't even get a brush saw into them, so you can just clear a path right into them. The only thing is you've got to get a different blade guard. I can't remember how much that cost, but our efficiency probably tripled once we went to this blade. It does a better job. It's easy. And like I say, it's a lot of fun.
Good deal. Thanks. We had a question come in that's really towards Ron and Jeff both, looking at labor capacity. Basically, how many people, man hours did it kind of take one to kind of set up and do the goats and monitor the goats, but also for the flaming work that you did, Jeff? Kind of how does that, yeah, basically how much does that, like labor wise, involve?
For flaming, it really depends upon how big the stems are and what's the density out there. The other thing to think about with flaming is you've also got to give your time for equipment setup. And you also need to make sure that you've budgeted time to go out there and put out any smokers, because you are going to have some smokers, unless you're doing it in pouring rain. And actually, we've done it in pouring rain. If someone wants to send me, yeah, it actually works real well because it's so hot. And you have, we're running, well, our big one is 400,000 BTUs, and that's 10 times more powerful than most people's backyard grills. If someone wants to shoot me an email, I can send the paper, which actually has the hours on there. It depends upon the density. So I'd be more than happy to share the paper. And I'll let Ron talk about, the time setup for the goats.
Yeah, for the goats, the time involved is really the setting up the fence. And in our trial, of course, we were clearing lines for the fence lines to create, perfect 1/4 acre paddocks. So that's very time consuming. But in an operational context, you're going to be putting the fence through areas that are already relatively clear. So you want to do minimum clearing to put the fence in. Of course, our farm crew was composed of 4. I think an experienced goat herd can do it with just one person, himself or herself. So, the fencing, the portable fencing, is very easy to set up and take down. It's ideal for this type of application. I will say that fencing costs are about $480 per acre. And that's for a 5-acre rectangle. I think that includes like a solar charger as well. And goats are probably running, $120 a head on the market if you're wanting to get into that. So, the initial expense can be kind of high. I did talk with one goat herd that's trying to start this kind of business here in Indiana. And I think she said that she charges about $900 to $1,000 per acre. So compared to conventional methods, that's probably going to be a little bit high. But but maybe those costs can come down over time. So.
Okay. Kurt, we had a question for you. Somebody wanted to see, basically, have you seen any downsides to annual burning to the invertebrates?
No, actually, the only study that I know of was done on springtails, and this would have been back in the 1990s. And so there was an increase in springtails, I believe, as a result of this. But I don't think that's a field of study that has been really exhausted. So I think there's a lot more to learn there.
Okay, great. Jeff, there was a question about the application of the flaming in higher quality natural areas. So did you have experience with that, or can you speak on the applicability of it for those higher quality sites?
I'm not sure what they mean. They mean higher site index or have a richer herbaceous?
Probably a more intact native community. So yeah, richer herbaceous community.
Well, I would think if it's got a pretty rich native herbaceous community, the invasives are probably pretty low. So you wouldn't have to do as much. What's kind of nice about using a flame weeder is that one picture showed, it's really just hits the area right where the flame weeding is, and anything which can resprout is going to resprout. I mean, one of the areas we didn't even know there's a seed pool for Dutchman's breeches, which is a native, bleeding heart, white bleeding heart. It's in the same group. And they just exploded after the treatment, which was really, I mean, it's really pretty to see too.
Nice, good deal. We had a question that came in kind of for all of us to address, and I think it's a good one, especially given our audience. Somebody wanted to know about funding, cost share availability for control of invasives on private lands, especially, and he said kind of even outside of the Farm Bill. But, you know, we have all these different methods we're talking about, but they have to be funded one way or the other. Can any of you speak to what have you seen as funding sources for private landowners that want to do some of this work?
Well, in Connecticut, NRCS, I think it was EQIP funding for riparian and wetland areas, was funding invasive, was cost sharing invasive control. That's the only one that I'm aware of is available. And I'm not sure, I think every state varies a little bit on how they hand out those funds.
EQIP is the principal one here in Indiana.
I know for Illinois, you know, we do have some EQIP. There is a program within NRCS called the RCPP, Regional Conservation Partnership Program, I think. And that gives the ability for local partnerships, organizations locally to write a proposal basically for a conservation issue, which could be invasive species, it could be something else. And it creates a dedicated pot of money that goes through the EQIP program or some of the other cost share programs directed at that particular issue. And I know in Illinois, we've had an RCPP that dealt with forest invasives before. So I think that's one avenue. You know, if you're an area you want to kind of build that option, it gives you more cost share availability. So I would definitely recommend looking into that. And the other thing I would recommend too is that a lot of places throughout the Midwest or throughout the U.S. now has local cooperatives, you know, whether they're called cooperative weed management areas or cooperative invasive species management areas. There's a bunch of different names. And those groups often do work with private landowners or seek out state funding or seek out other funding to provide some cost shareability in local areas. And so if you have one of those in your area, that may also be worth investigating or even getting involved in, for sure.
So the only other thing I would add to that is that if we think about invasive species control as part of a larger project, I think the options for funding might increase. And so in that sense, there might be many other private foundations or government sources of money that would be available as well. So kind of linking the control to another project of some sort.
Yep. Very good point.
Actually, Chris, and if you don't mind, I might go back to the earlier question you had for me about the invertebrates.
Sure.
It wasn't necessarily a scientific study, but it was part of a monitoring program a couple of years ago. We had a woman who's publishing a study of her own on the bees of the Southern Great Lakes region, Laura Raraika. Anyways, she came out here and wandered through the annually burned plot and found it was actually one of the richest areas within the whole arboretum that had a high population of native bees. So we had overall throughout the entire arboretum, we had over 100 species of native bees that she was able to document. But her recommendation was continue burning. And, the response that the ecosystem has provided, by, increasing species richness really gives more opportunities for a lot of these bees to utilize those plants and the vegetation.
Okay, great. Well, question came in for me about the drill and fill or injection for tree of heaven and what herbicide. We've used triclopyr and had decent luck with it, although we've had some sprouting. We've also starting to look at imazapyr, and that seems to be fairly effective. And so I think that's one of the recommended herbicides. You just have to be careful with the amounts you put in and your per acre application and things. But it does seem to be a very effective injection herbicide for tree of heaven. Ron, we had a question about, you talked about the herbaceous layer and the diversity and richness. Did you look at all with coefficient of conservatism or what actually changes in the species composition? Like, were you getting changes in that, or just weedy species, conservative species, kind of how did you look at anything like that?
Yeah, good question. Yeah, we actually documented every species or species groups. And so most species, there were no differences in terms of the number of the sample quadrats that had those species versus between the different treatments. There were some exceptions. We did find a real reduction in fern cover, not fern distribution necessarily, but definitely a big reduction in fern cover. So that's one. You think about deer avoid ferns generally, but with goats seem to relish it and they'll readily consume it. So in some places, ferns are a hindrance to desirable forest regeneration because of high deer populations and high fern populations. But with the use of goats, it definitely can reduce the fern populations.
All righty. Jeff, somebody had a question wanting you to about your methodology when you cut the plants and then let them sprout back before burning them. Basically, they asked, why wait until the sprouts versus just treating the stumps at the point of cutting?
No, and that's a great question. The reason why we waited is we wanted to have them resprout and deplete as much of the stored carbohydrates in the root systems before we treated, to lessen the chance that there could be some other buds below ground which could resprout vigorously. So we wanted to, like I said, weaken the root system and have any buds which we might have missed with the initial, if we had just flamed right away. We just thought we'd have better success.
Okay, good deal. Ron, a question about fencing. So did you ever have any issues with shorting out of fencing with something falling on it, or did you have problems with goat escapes at all?
Yeah, so there was only one time when we actually lost a goat, not permanently. We recovered her. And it was a period where there was some pretty intense rain. The ground had gotten really soft. And in one section of the fence, it just laid over. These fences, you just kind of step them in. There's not a large amount of the fence that is driven down into the ground. So it's not real deep. So when the ground got real soft in one section, it laid over, and we lost a goat that way, but recovered her. We had no problems with predation. I mean, the Southern Indiana Purdue Ag Center is in a fairly remote location. We do have coyote herds around, or packs around, but we had no predation. The fencing was, I think, very effective in deterring that. Occasionally a limb would fall on a fence line, but we didn't really, with fairly frequent monitoring, we were able to catch those quickly and rectify it. So really not a problem. The netting is very effective.
Okay, great.
If I missed it, did we get to the sedge meadow question?
Oh, the sedge meadow question.
Yeah, because that was actually the top voted question that I almost missed. So it was specifically, would you recommend the direct flaming method for controlling thistle in a sedge meadow? And I guess if the answer is no, what would maybe be a more suitable method? That's not a woody question, but I'll allow it.
I was gonna say, the only thing I know about sedge meadows is when I was growing up in Ohio and I had to clear them out of bloody hayfields. And they have a pretty big root system on them, so I'm not sure how effective flame weeding would be. They could give it a try, but I suspect it's going to resprout. I mean, flame weeding, I actually use it on stiltgrass in my yard, but it does not work on dandelions in the yard. And I would think that would. So I just would be very skeptical of it working on a herbaceous plant with a large taproot in a meadow situation.
Okay. In terms of what you asked about what would be a recommended method, I would think with thistles, I think a directed herbicide, a selective herbicide would probably be the best way to go about with that one for sure. You can get a lot of selectivity depending on the site and the species that are along there as well. You've got a lot of choices. All righty. Well, I definitely want to thank all the speakers and for the great presentations and really good discussion for this session. And I definitely encourage everybody to continue with our symposium for the rest of the day.
We're on to the herbicide section next, actually. So we had a lot of good questions about that, and I think the next section will be really helpful.
Great.
So thank you all so much, and see our audience again real soon.
Okay, take care.
Thanks.
Thank you.